Okay, so
Objective. In the above, the conic as the curve of intersection.
okay, so remember how I talked about the other day, if you slice two cones, that if it went through them, it would kind of like be two parabolas, and that's what she's showing here.
Between a right circular conical surface and a plane that cuts through both halves of the cone. A hyperbola is the locus of a point which moves so that its distance from a fixed point called the focus bears a constant ratio which is greater than unity to its distance from a fixed line called the eccentricity and is.
Okay, so this is a lot of terms that we're not going to use. Have you heard the term focus? Okay, we used focus with an ellipse. So these have a focus. Notice that it is inside the curve. If you think of that as being kind of like a sideways parabola, the focus is inside the curve, just like it was inside the ellipse. Eccentricity, directrix, don't worry about those. We're not going to use those terms. Let's keep going.
Denoted by E. Points A and A dash are called the vertices of the hyperbola.
Okay, again, she's using some more advanced things that we're going to use. Those points that are labeled A and to the left A prime, those are the vertices of the curves. Just like if these were parabolas, those are kind of like the rightmost or leftmost points instead of being the highest and lowest points. So those will still be called the vertices. Don't worry about the little lowercase a. We're not going to be talking about that.
The line AA dash is called the transverse axis of the hyperbola.
Okay, we will talk about that. So the transverse axis is a little line segment that connects the vertices.
If 2 points B and B dash are taken on the y-axis such that CB is equal to CB dash
Don't worry about all this.
equal to B, then the line B dash is called the conjugate axis of the hyperbola.
Okay, the conjugate axis is this other segment not between the vertices. We'll talk about that and how to find that. And then notice those two purple lines that were graphed that make an X. Those are called asymptotes of the graph. And they actually will define how wide or narrow the curves are. So we'll talk about those and how to find those.
The middle C of A dash is called the center of the hyperbola.
So that's the center.
Because it bisects every chord that passes through the equal to.
We're not going to deal with this.
Let P, XY be any point.
This is what defines a hyperbola. This is why we can't use a
The
string.
distances from P to the two foci be to A. That is, PF dash minus PF is equal to 2A.
Okay, so that when I said it's defined by some difference being consistent, that if you took this length of the pink segment and this length of the pink segment and subtracted them, then you get this constant that equals 2a. And no matter where you move that green point on the hyperbola, that difference is maintained. So it's not a simple thing to just draw like with a string and some pins to secure it. It's kind of complex.
We obtain the standard equation.
This might be all. Oh, does that look familiar? Whoops.
No.
Yes, maybe. Ah.
It's
B squared is equal to 1.
Sounds familiar.
Okay, but something's different. There's a minus in there. Otherwise, that looks like the formula that we used for ellipses, right? Okay.
The hyperbola 0 and equal to is the line of the lattice, the hyperconjugate and transverse axis.
Okay, this one is what we call a vertical hyperbola. So the curves are going up and down instead of left to right. But the segment that goes from A to A prime is still called the transverse axis, and that other one that doesn't connect the vertices is still called the conjugate axis. And this might be all we need to see. right, notice at the bottom, x squared over a squared minus y squared over b squared, still a negative term. Okay, I think that's all that we need to view from there. So let's put this into some notes. Okay, so just think hyperbola is like two opposing parabolas, kind of. Okay? All right, so let's take a look at how we can compose this. And I think I'm going to use some graph paper for these notes. Oh, while I'm getting my graph paper, go back and get a ruler. You may have someone who was lazy at your table and didn't return theirs. Are you recording? Yes. Grab a ruler. Okay, so let's start with what the standard form of the equations look like. And they're going to look very similar to the ellipse formulas that we had. Oh, y'all, that's a minus. Yikes, that's a minus. Okay, so the similarities that you might notice are the x minus h's and the y minus k's and the a squareds and the b squares. But there is a minus as opposed to plus with an ellipse. And these can be vertical and horizontal just like the ellipse. So if the x term is the positive term, I would call the y term the negative here because it's following the subtraction. So if the x term is positive, then you have horizontal curves, which means they open up left and right. If the y term is positive, and the x term is being subtracted, then that's what creates a vertical hyperbola, where the curves are going up and down. If the x term is positive, then you have a horizontal hyperbola, and the curves go left to right. If the y term is positive, then you have a vertical hyperbola, and the curves go up and down. Yes?
So is it if like the x term is over a square, then it would go out like this? Or is it like if what if there was like a negative in front of the x?
Okay.
It was still
Okay, so if there was a negative here, there would have to be a positive here for it to be a hyperbola.
Okay, and then
So with a hyperbola, only one of them will be negative.
okay, so always it's the one in front is going to determine.
The positive one determines which way it goes. Okay, so in this case, I would say a squared is associated with the positive term. It's not necessarily the biggest denominator. With an ellipse, we said a squared is your biggest denominator. A squared here is associated with the positive term. So if you're always putting the positive one first, a squared is your first denominator. May or may not be the largest denominator. Okay. Alright, so we're going to jump into one and I'm going to show you how to graph it. And we'll find the vertices and the foci. Let's throw center in there too. There's our equation. Okay, so as far as the center goes, it's the HK value still. Alright, so in this one I have X term being first, so I'm looking at this format. That tells me I should end up with a horizontal hyperbola. Curves going left and right. What's the H and K if that's the equation? Yeah, center is at the origin here, because there's nothing being subtracted from the X and Y. Okay, so let me show you how to graph these. There's our center point at the origin. Okay, using this, a squared is under the x here, so a squared is 9, which tells me a is 3. B squared would be under that y term, so b squared is 4, which means b is 2. Okay, since this is horizontal, I'm going to do this. In the x direction, 3 is the square root of 9. So from the center, in the x direction, I'm going out 3 both directions. And I just put a little dash there. Since there's a 4 under y, the square root of 4 is 2. Y-axis goes up and down. So I'm going up 2 and down 2 and make a mark. Okay, use those dimensions there to think of this as a rectangle. And I'm just going to mark the corner pieces, corners of this rectangle. Okay, so remember the x's that I said were asymptotes of the graph? This box determines where the asymptotes go, and the asymptotes determine how wide or narrow the curves are. So what I'm going to do for the asymptotes is dot this diagonal and the other diagonal. So I'm actually graphing the asymptotes before I even graph the curve. Okay, so these establish, again, how wide or narrow these two curves will be. So x term was the positive. That tells me that it will be horizontal. So these numbers where I went out a, where I went to 3 and out to -3, those are actually the vertices of this hyperbola. If it was a vertical one, then those would be the vertices. The other 2 points that I went out to make the box. So then you're going to just go to your vertex and sketch the curve as wide as those asymptotes will allow. So you just go right up against, just snug up against those asymptotes. Don't go over them. But that establishes the width of each curve. Okay, so what I just drew, that is the hyperbola. All these other pieces determine where that hyperbola is and what it looks like, but that in itself is the hyperbola right there. Okay, so as far as going back and answering the question, what are the vertices, those are the points that we just started sketching from. So that would be 3, 0, and negative 3, 0. And I'm going to do that since someone was already asking about that. Because I went over 3 and over 3. And the reason I went 3 is because there was a 9 under the x term. And the square root of 9 is 3. Okay, so you can write out 2 ordered pairs or write it that way. Okay, so for the foci are going to be somewhere inside each curve. So it's going to be a distance greater than 3. The way we find that is by using the Pythagorean relationship a squared plus b squared is c squared. So that one's a little more easy on our brain as opposed to the one we used with ellipses. So a squared was 9, b squared was 4. That makes c squared 13. And c is square root of 13. Okay, how much is the square root of 13? Between 3 and 4. Okay, so I will just go and plot somewhere like here. And just say there's the focus and there's the focus. Okay, but what is that ordered pair really?
3.
I went this far.
0.
3 plus
3 plus square root of
square root of 13. 3. I need 0.
Okay, square root of 13, 0. Right, it's still on the y-axis. I'm sorry, that's the x-axis. But I only went out from the origin square root of 13. So that means that ordered pair is square root of 13, 0. And this one would be negative square root of 13, 0. Is everybody okay with that? Mm-hmm. Okay, so labeling some of the things that that I mentioned earlier. Let's label this right here. This segment that connects the 2 vertices is called the, do you remember? Transverse or conjugate? Transverse. You know, you had a 50-50 shot. Transverse axis. And if I went right A and left a distance of A, how long is that transverse axis? 2A. Okay. Then this distance here, that doesn't really connect anything except what I used to make the rectangle, that is called the conjugate axis. And it has a length of 2b. Okay, then we have these dotted lines that we drew, and the dotted lines are the asymptotes. And asymptotes are lines that graphs approach and get closer and closer to. Okay, so let's talk about how we would write the equation of those asymptotes. Okay, they're lines, right? So we could use y equals mx plus b. How would I find the slope of, let's take this line here with the positive slope. How could I find the slope? Count, rise over, run. So if I start at the center and go to that corner, I would rise 2 and run 3. So that slope would be 2/3. And this slope would be rise 2, run negative 3. So that slope would be negative 2/3. And then we can see that they cross at the origin. So we can just use the rise over run method to calculate those slopes when we need to. Okay? Alright, are we good there? Alright, I used C down here but I didn't really talk about C in depth. Let's make a note that C is the distance from center to a focus. Which was the same that C represented in the ellipse. Okay. Lots of different pieces and parts going on there. Okay, let's graph a vertical one this time. Okay, find an equation of the hyperbola with foci 0 plus or minus 3 with conjugate axis length 4 graph and find asymptotes, which means find the equation of those asymptotes. Okay, so let's start with our graph and plot the information that we have. And see if that helps us, because I don't know if this is horizontal or vertical yet. Okay, foci are at 0, 3, and 0, negative 3. Okay, well, remember the foci are inside the curves. So is this vertical or horizontal? It has to be vertical. So my curves are going to be like this and like this because the foci are inside the curve. So it can't go this way. Then they wouldn't be in any curve. Okay, also I'm given what kind of value here? A, B, or C? A goes to the vertex. Not B. C. C is 3. Remember I just said C is distance from center to focus. So I can tell by... not yet. We'll get there. Okay, so my distance from center to focus is 3. So that's the C value if I'm talking about A, B, and C. Okay, so I can find the center. Where's the center? Georgia, it has to be right in the middle of those. So I know that that's the center point. I know it's vertical. Okay, so if it's vertical, I'm going to use this as my model. And I know that the center is 0, 0, so I know H and K are 0 and 0. Okay, what about this now, this conjugate axis length 4? Conjugate axis does not connect the vertices. So conjugate axis goes this way. If it has a length of 4, then that means I'm going 2 to the right and 2 to the left. Okay, but that's also giving me A or B. B, which is, how far was that? 2. Okay, so from the information given already, I know that C is 3, I know that B is 2, and I know it's a vertical hyperbola. Okay, I know the center is 0, 0. Well, that's H and K. H, comma, K. I have B. For my equation, I need A squared and B squared, so how do I find A? Pythagorean theorem. So A squared plus B squared equals C squared. A squared is what I don't know. B squared is 4. C squared is 9. So what is a squared?
5.
And what is a? Okay. Okay, how much is square root of 5?
20.
Just barely more than 2, right? So that means barely more than 2 will be my vertex. Barely more than 2 this way will be my vertex.
So if it gives you the conjugate axis, like you already know, like B.
Yes.
But if it says like the transverse, that would be A.
Correct. Okay, so I can go ahead and write the equation because my equation needs h and k. Those are zeros. I need a squared and b squared, which I know. Okay, so this equation will be y squared over, what was my a? Square root of 5, but a squared is 5, minus x squared over b squared, which is 4, equals 1. So that's the equation. Any questions on the equation? Okay, let's go back and sketch the graph. Okay, so remember we went up to the vertex, we went out to this point, so think of that as a corner there, corner, a corner, and a corner. With the A and the B values, that's what you're using for that rectangle. Dot those diagonals, which will be the asymptotes. Okay, it's an up and down vertical. So start at the vertex, go as wide as the asymptote will allow without crossing over it. Okay, so we found the equation, we graphed it, now we're going to find those asymptote equations. So if I think of y equals mx plus b, what is the b for both of these lines? What's the y-intercept? 0. Okay, so I know that the b is 0. To find the slope, start at the center, count rise over run up to the corner. Rise 2, run 2. That's not right. Oh, we rose square root of 5, didn't we? It looked like 2 on my graph. Remember, A is square root of 5. So I went up square root of 5 to the vertex and over 2. So that's my slope. Square root of 5 over 2. Times x, that's mx, and then b is 0. So you can write that in or not. Because their y-intercepts are at the origin, that's where they're crossing the y-axis. Just looking at the graph. I'm going from the center to a corner. And this the center happens to be at the origin, so that's also the y-intercept. We'll do one in a minute where they're not crossing at this origin. Rise over run. Just count rise over run from center to a corner. Okay, so how much for this one? I rose square root of 5, but I ran negative 2. So that slope is negative square root of 5 over 2x. Questions on that? Huh? Mm-hmm.
6.
5.
5.
Everybody good?
Wait, why equals 0?
Yes. Huh?
Why equals 0?
Because your B, remember, is your y-intercept. And where do both of these lines cross the y-axis at 0? Okay. Any other questions on those? It's a lot. Remember when you're working on that review, I said that you could put notes on it. So put any notes that you want on that review, and we'll be working on it all day tomorrow. Okay, example 3. Graph. Then find the center, the vertices, the foci, and the asymptotes. And the equation is x plus 2 squared over 9 minus y minus 5 over 16. Okay, is this vertical or horizontal? Horizontal, because the x term is positive, so I should end up with curves that are facing left and right. What is a squared? 9. Therefore, a is 3. B squared is 16. Therefore, B is 4. Should we go ahead and find C while we're at it? I'll say yes. Okay, so a squared, B squared equals C squared. So 25 is C squared, which means C is 5. Okay, so we know A, B, and C. Without graphing anything, we can determine the center. Where is it? -2, -5. And yeah, the H and the K. Okay, let's go ahead and start graphing some parts, and then we'll come back and fill in those. Alright, so my center is -2, -5. That's down in the... Ooh, that should be a +5, y'all. Nobody caught me on that one. The 2 is, but not the 5. Yeah, you just ignore that. The negative tells me it's a hyperbola here. So still take the opposite. Wouldn't make it a +5 there. Okay, yeah, that was a good question. If there is a minus here, just take that as, oh, this is a hyperbola, and don't think about distributing it there. Still take the opposite sign within the factor for your K value. Alright, so 2, -5, that will be in my second quadrant. I said that backwards, didn't it? -2, +5. That's the center. Ooh. Might need more space. Okay, so the next thing I would do is create the rectangle. So your A value was 3. And I know that this is horizontal. The 9 is under the X term. So I'm going left and right 3 from this center point. From the center, left and right 3, because the 9 is under the X. So I use that value for A. Right, under the Y term is a 16. Well, the square root of 16 is 4. Uh-oh. So I've got to go up 4 and down 4. didn't do a very good job spacing that. Okay, so I'm going to find those corners, which are up here in my problem, and draw the dotted diagonals that represent the asymptotes. I went right and left 3, up and down 4. Those dimensions determine the rectangle and the corner points. Everybody good so far? Okay, question. Did you figure it out? Okay, who else has a question? Okay, all right. So we know that this is horizontal, again, because the x term was the positive one. X-axis goes left and right, semi-curves will go left and right. So this right here where I went left and right to establish the dimensions of that rectangle, those are the vertices. So there's a vertex there and a vertex there. If it was vertical, then I would use these two as the vertex. So this is a pretty wide curve here. Those,
You went up 4 and 4, or up and down 4 from the center?
yes. Uh-huh. Okay, so this one's a good bit wider than that last one. It's because the way the rectangle is arranged and those asymptotes, that's what will determine how wide or narrow your curves are. Okay, so what I just graphed is the actual hyperbola. That point that I started drawing from, those are the vertices. So what is this vertex over here? What's that ordered pair? 1 over 1, 1, 2, 3, 4, 5. So 1, 5 is that vertex. And then this vertex over here is negative 1, 2, 3, 4, 5, and up 5. So negative 5, 5. And now for the foci. Okay, so we got a C value of 5. Remember that C is the distance from center to focus, right? The foci are inside the curves. So the foci are going to be somewhere right in here. But I have to go 5 units, because C was 5, from the center. So 1, 2, 3, 4, 5, there's a focus. 1, 2, 3, 4, 5, there's the other focus. Okay, what is that ordered pair? 3, 5.
Wait, how did you
Okay, so I figured out the C value, that was 5. And then I have to realize that C is the distance from the center to the focus. And the foci are inside the curves. So I wouldn't go this way 5. I wouldn't be inside the curves. I go this way. And then once I plotted them, I had to figure out what the point was. So this one is negative 1, 2, 3, 4, 5, 6, 7, 5. Okay, last thing here is to figure out the asymptotes. So think y equals mx plus b. Now, you guys have an advantage because I've used graph paper here so we can actually see what the y-intercepts are. We don't have to find them. This y-intercept is right here, which is 1, 2, 3, 4, 5, 6, 7, 8. And this one is at 2. Okay, but what about the slopes? Start from the center and count to a corner. Rise over run. I went up 1, 2, 3, 4, and over 1, 2, 3. So that slope is 4 over 3. So the first equation is y equals 4/3 x plus y-intercept of 8. And I knew the y-intercept because I just counted on the graph. Now if it's a fraction or something, it's not so simple. Okay, the other one, the slope is still rise 4, but run -3. So it's -4/3 x, and its y-intercept is just 2. So plus 2. Question? Okay. All right. 2 more to go. This next one we're going to write the equation again, and then I have one more that we'll graph that you might actually be familiar with the last one. You might have seen it before. Okay, write the equation of the hyperbola with transverse axis endpoints -2, -1, and 8, -1, and conjugate axis length (8). Write the equation of the hyperbola with transverse axis endpoints -2, -1, and 8, -1, and conjugate axis length 8. Okay, the transverse axis connects the two vertices. Okay, so basically these are vertices. Okay, and even though it doesn't say to graph it, I'm just going to sketch these to give me a little better visual of what's going on. Okay, -2, -1, and 8, -1. Okay, if those are the endpoints of the transverse axis, then these are the vertices.
Okay, so I thought the transverse axis, that's in between.
Transverse axis connects the vertices. And the conjugate axis is the other segment that determines the size of the rectangle. Okay. All right, so if I have the endpoints of a transverse axis, then I'm given the vertices. Okay, the fact that these are the vertices tells me that this is what kind of hyperbola? Horizontal. Okay, so my graph has to go something like this. I'm not going to graph it, but it's got to go that way, right? Okay, so that tells me that I need to use this, x minus h squared over a squared minus y minus k squared over b squared equals 1. So that's the format of the equation. Do I know h and k? Do I know the center? Okay, I don't know it yet, but I can find it pretty easily, right? It's got to be halfway between these two. So what point falls halfway between those two? 3, -1. Okay, so just walk it in or average the x's, and I get an h of 3 and a k of -1. Okay, so we can fill that in. This becomes x minus 3 squared over, we'll fill that in a minute, minus y, that's a -1, so when I subtract it, it becomes +1 over, we'll have to find b, equals 1. Okay, so do I know a or b? Actually, know both. If this is the center and that's a vertex, then A is 1, 2, 3, 4, 5. So A is 5. So that means A squared is 25. We'll go right there. Okay, do I know B? Yes, I do. If conjugate axis has length 8, that means that this is 8, but what is B? That tells me that B is 4. So 4 squared is 16, and that is my equation. Okay, who has a question? All right, I think we can almost, or maybe, get finished with this last one before lunch. If we can't get finished, we'll just wrap it up right after lunch. Okay, so you've actually seen a hyperbola, I believe, in another class that's called a rectangular hyperbola. And the equation for these look really, really different. For example, that's the equation of a hyperbola. I'm not lying. Okay, to graph it, I'm going to put it in this form. Do you see where I got that? Multiply both sides by x. Okay. So we're just going to be really old school here and just generate some ordered pairs that I could multiply and get 4. So what's one that I could use? 4, 1. Is 1, 4 different? Yeah, that's a different order pair. Okay, what's another obvious one? 2, 2. Okay, give me a decimal. 0.5 and 8, but that's, 8 and 0.5 could be used, but that's a different order pair. Okay. What else could I use? Yeah, I could make all these negatives, right? I could use -4, -1, -1, -4, -2, -2, -0.5, -8, -8, -0.5. Okay, all right, let's plot those points. See what we get. Those are just the positive ones right there. If I connect those, what will that look like? Kind of like a parabola, doesn't it? But so do the others. but it's sort of oriented crooked. Okay, then I'm going to plot the others, the negative ones. Have you seen a graph like that before? Yeah. So you've probably graphed 1 over x. It's probably the hyperbola that you've seen before in another math class. So that is still a hyperbola, but it's not vertical and it's not horizontal. Do I have 2 asymptotes? Are there lines that the graph is approaching? Yes. They are approaching both of these axes, the x-axis and the y-axis. So those are the asymptotes. What are the equations for those lines that I just dotted? X equals 0 and y equals 0. And that's like the name of the x-axis and the y-axis, right? Okay, so answer this for me and then we'll run to lunch. Could I let x be 0? Could I let y be 0? No, because if either of these is 0, the product will not be 4, right? And so that's another reason why we have these asymptotes. We just don't have a point where x is 0 and y is 0. It doesn't exist. Okay? All right, run to lunch and we'll finish up after lunch. Well, I'm done with notes, but I'm going to start one problem with you on homework. Okay, guys. All right, number 49 we are doing together.
Wait, which one is this?
Yep, sorry, should have been here.
No, I
Sure, yeah, I don't care if it comes first in your homework. Okay, so it says to graph it and all we wanted to do with this one, all I want you to do with this one is to put it in standard form. Which means we need to complete the square. Okay, so we're going to do this just like we did with the ellipses. And the first step was to do what? Group the x's, group the y's. Okay, now the y's get a tad bit tricky because you know in the standard form there has to be a minus in between, right? So let's go ahead and factor out that negative, which makes that a 4y squared and a minus 8y. And the 4, I'm going to move over to the other side. Everybody okay with that? So I went ahead and recognized that, hey, I need a minus, so let's just factor out that negative, making this positive and this negative. Okay, what did we do next? Factored out that lead number. So I'm going to factor out a 9 here. X squared minus 4x, leave your space, minus 4 y squared minus 2y, leave some space. Okay, so then we do the little step that will create perfect square trinomials. I'm going to take negative 4, divide by 2. That gives me negative 2, square it to get 4. Over here, negative 2 divided by 2 is negative 1. Square it, get 1. So I'm going to add 4 and add 1. Did I really change the left by just 4? It's 36. So I'm going to add 36 to the right. And this was not really a 1 because it gets multiplied by the negative 4. So I will subtract 4 or add negative 4 to the right. Ready to get on that. Okay, next step is to factor the perfect square trinomials. So I have a 9 times x minus 2 squared minus 4 times y minus 1 squared equals, add that up, I just get 36. And then one more step, this needs to be a 1, so I will divide everything by 36. And 9 over 36 reduces to 4 on the bottom. Did you add 36? And then subtract 4?
Oh.
Got it? And then this simplifies to y minus 1 squared over 9 equals 1. Okay? Question? That was the only one that you had to complete a square. So that sort of doubles as a notes/homework there. Okay, that's it. So you have the rest of the time to work on your homework. Tomorrow we work on the review. Friday will be the test.